Hello YouTube world, this is Logic Crazy and I'm Jonathan. Here's yet another tutorial on creating a chess engine. So we have made all these possible moves that so far just return blank strings, and in this tutorial we will be working on creating some possible moves for the king in the format outlined in previous tutorials as x1, y1, x2, y2, capture piece. And before we do that, there's one little thing that I would like to do, and that is in the, we'll put it right here at the top of the main, we want to create a global variable. So we'll create, outside of the main, we want a static global thing. So we'll make a static integer, and we will call it king position C. Alright, now what these variables will do, and we'll create another one, and this one will be L. And what these two variables do is C and L stands for capital and lowercase. So this variable will monitor the position of the whatever king is the capital, so in this case this A here, and the L will monitor the other one. And it will not monitor it in the way of a X and Y or row column sort of way. It'll monitor it in a solid number. So as this being 0, 1, 2, 3, 4, 5, 6, 7, and then 8, 9, 10, and all the way to the last one being 63. So that's how these numbers will be. So if it's 63, then maybe A is over here, or here, depending on which corner you're starting from, which we'll discuss later. The reason I like to keep monitors of the king is because it's always good to know where the king is, in the fact that when you make a move, you want to make sure that that move doesn't put the king in check, your own king in check. Say a pawn is defending my, or a bishop, let's say, is defending my king, and if by moving my bishop, perhaps that puts my king in check, and obviously that would make that move illegal. And so you have to always be knowing where is my king to know if you can make a move. And it's best just to keep a variable and keep it updated whenever you move the king. Update that variable of king position instead of each time you make a move looking for the king and basing it off of that, just for the sake of speed. Alright, the first thing we're going to do here is, let's see, we're going to create one more thing. We're going to create a string which is list, and we're also going to create something called old piece. Now I'm starting with A because I believe it's the simplest. Pawns, there's all these rules about sometimes it can move forward 2 spaces, sometimes just 1. It can capture to the right or to the left. There's pawn promotion. King has less things it can do, although king can do a castling. That's a fancy feature that king can do, but we won't be worried about that just yet. Now remember to comb through each one, such as this, having a 4 for I equals 0 to 64. I'll just copy this because I'll be needing it later. We use I divide by 8 and I modulus 8. And so in order for the program not to keep recalculating these values over and over, we'll just create integers that do them once, and it'll speed up our process. So we'll say int, we'll say R equals I divided by 8, so I'm talking about row and column, and then of course C equals I modulus 8, which is the percent sign. Alright, these are our two variables. Now I will paste in this for loop just for ease, but we're not going to go with 64. We want to go with 9. Just for let's see. Oh, that is one thing I would like to change. I don't want this to be I, for the reason that I is already called in here, and I can't create, and I want to use a separate value for I. Now, the reason I say I from 0 to 9 is because for a king, there are 9 places he can go, in a sense. Let me just open Arena to show you a little bit about what I'm talking of. But basically what we're going to be doing is combing through each of the places a king can move. Alright, so here's a game. Take this king right here, surrounded in the pink. The king has inevitably sort of 9 options, including the place where he is. But he could go here, here, here. He can go in all these places around him, and if you add them up, 1, 2, 3, 4, 5, 6, 7, 8, and where he is 9. But 3 rows of 3. He can go all around himself. And so that's why I picked 9. It combs all around him, and we'll have to obviously avoid the location he's at. So what we'll do is right away inside here we'll say if it would be j is not equal to 4, because it's 1, 2, or it's 0, 1, 2, 3, 4. That's the middle one. So if we're not moving to ourself, because we don't want to check that, that's not really a move, that's just staying, then here's what we do. What we want to say is we want to know if the place we're moving to, is it a blank spot or is it a lowercase? Because back here, let's say this pawn was right here. All right, I can't move it there. It's probably not my turn, but or it's checkmate or something. Anyways, but it's not that. But anyway, if my pawn, all right. If my pawn was right here in this blank spot where this arrow is pointing to, then I would not be able to move there because I can't jump on top of one of my own pieces. So I need to know, is one of these spots either blank or lowercase? Alright, so here's how we would write this. We would say another if statement here. If, and the way you would do lowercase is, sorry, my machine is going really slow. I've been running a bunch of background processes that you can't see. I should really have quit that. And it's going terribly slow. Yes. Character dot is lowercase. All right. Wow. Should really close this there. All right. I'll leave that. All right. So if it's lowercase, and what lowercase? Well, chessboard. And where is this chessboard located? Well, obviously the place that A is located, the king is located at I. So what I'm going to say is take this R spot and say R minus 1 plus, it would be J divided by 3 in this case, because we're doing this loop of 9. But basically, R minus 1 plus J divided by 3, and then the other spot would be C minus 1 plus, and you guessed it, J modulus 3. And of course 3 because we're doing 3 rows of 3. Now, what we want to know is, and then we want to do, because we're talking about character, we want to do char at 0. Because it only checks characters if they're lowercase. It can't check a string because obviously a string could have more than one thing. Alright, so it wants to know if that, and then I'll just add some brackets outside, but that is if the spot is lowercase. We need an or. We need to know if it's blank. And so the way you would do that is say if blank dot equals, actually let's just do it a little bit different. We'll just say if blank equals, and then I'll just copy this chessboard because it should be exactly the same. Alright, and I'll show you that it puts a little notice here, and it turns our icon to yellow. One warning. And this warning is very important, and it'll say use the equals. If you click on that, it'll just convert it for you. I was going to type this way first, but just want to show you. If you just say an equal sign, it will not produce true when it should produce true. And it will, anyways, it's doing what it's supposed to do, but it's not thinking the way you would expect it to. And so this is dot equals thing actually checks is this the same as this, as in a space. So anyways, that's always what you want to use when comparing strings, is a dot equals. Just a helpful note so that you don't run into too much difficulty later on. Now, what we're going to want to do is we're going to be moving our king. And so what we will say is we created this old piece thing before, this string, and we'll say old piece equals, and then I'll just paste in this thing. There we go, and put a semicolon in there. So old piece, oh, I had spelled this wrong. There we go. Old piece equals that. And then we will say chessboard RC. Remember, RC is the location of the actual king. This is the location where we're taking the king. So we want to say, obviously, this becomes blank. The place that, what we do is we take the place where the king is, and we make it empty, and then we take the place where we're moving the king, and we make it a king. But we also, suppose that another piece was right, let's say a white pawn was right here, it also has to know, aha, I'm moving here, but I'm taking a pawn, so that when I go back, I don't just set this spot down here to an empty spot. I put that pawn back there. So that's where we're memorizing what the old piece is. Was there something there? Just in case there was something there, such as a pawn or something, some lowercase letter of the other opponent's piece. Do that. And then we will say, take this chessboard to where we're moving it, and that should obviously be an A. Set that to A. So the old spot's blank, the new spot's A, and the old piece, whatever used to be there, has been recorded. Alright, just give me a second here. Alright, sorry about that. Now that we've set this, we've moved this piece, we want to know, is this a valid spot? As in, does this put my king in check? For instance, there's two kings. For instance, this king right here can't move right here. The reason why? That puts it in check. It also can't move here. Those places put the king in check, and so therefore they're limited. So now that we've moved the piece there, I want to know if king, we'll call it king safe. If king safe, do this. Now what we need to do is create a king safe method. So we'll just, for now, just put in a public static boolean king safe. And this king safe will, for now, we'll just have it return true. But later on, this king safe method will check, in this current board, is my king in any danger? And so that's basically what this king safe will return. But we will leave it as true for now. We won't. We'll basically ignore it. We'll assume it's always true. So we've moved the piece there. One thing also that we would have to do is say king position C equals, because we've moved the king, we need to now update the location of the king. And the way you would do that is I plus, and in brackets, j divided by 3 times 8. And let's see, plus j modulus, whoops, small j, modulus 3 minus 9, I'm going to say. All right. That, I believe, will give you the position. Just thinking this through here. Yes, I believe that will give you the new updated position of king C. You can work through the math on your own to see how exactly that might make sense. So we've updated the king's position. Now the king checks, oh, in this new position, is it safe? And let's just say after we've checked this, we'll ignore what happens if it is safe, but let's assume we're done checking, whatever that is. Now we want to put the king back. We've moved the king, but we're just coming up with moves. Now we put the king back. So now we would say chessboard RC equals A. Set that one back. Now we set our old one to whatever the old piece is, right? And then we'd set the king position. King position C equals, and we'll set it to, let's see. That is one thing I would have to add. We're going to create a right about here, right after this chessboard turns to A, we're going to create a integer, and we'll call it king temp equals king position C. Alright, so now we've recorded where the king used to be when updated. So now instead of doing some more math, we can just say it equals king temp. So we recorded where the king was, we changed where the king went, and then we restored the king to its original value. Alright, now what happens when it is safe? Well, we want to record this move. Whatever this move was, from this spot, from RC to this complicated math, we want to record that move. And so the way you would do that is we'll say list equals list plus R plus C. Remember, it always tacks it at the end. It's not doing a mathematical addition because you're starting out with a string. That's why I have list equals list plus, is because otherwise the first variable would be a number, an integer, and it would start doing arithmetic. So we want to just append it, put it to the end of the string. So we're going to add RC, so that's the initial x1, y1, and then this would be, we'd have to put this in brackets, of course, so that it does do arithmetic on that one. And then we would do, so that's the x2, and then we would do, in brackets again, that one. And then we will say plus old piece, because we want to record what was captured. Put a semicolon at the end, and you shouldn't have any errors. That is roughly what your program's supposed to look like. There is one other thing we'll be doing, and then we'll return list. And I'll just put a comment here. Need to add castling. Need to add castling later, because castling is recorded in the A moves, not in the rook. because the king moves 2 over. That's how graphical user interfaces work, and so that's how I program it as well. And it just it works a lot better than having the rook think about it. And one thing that you have to think about is, for instance, let's back to our thing here. Actually, I will set up a position. That way I can move stuff around. All right, let's say we have a king here, way over here in the corner. Now, if this king, okay, in the king here, the white king here, I'm just making it white, we can check all these spots, and they're all valid locations. But when we go here, we are checking up here where there is no array. It's going to come up with negative places where the chessboard doesn't exist. And so it'll actually come up with errors in our current situation if you're near the edge or things like that. So we need to have a bit of an error checking situation. So within this loop here, we're going to add a couple things. We're going to say the way you allow for errors and just get it, if there's a problem, just skip this try and jump onto the next square, and so on. So what you would write in is try. Simple enough. Put a bracket there, and then indent all of this. Now, after the try, you try this, but then you have to put at the end catch, and then we'll put it exception E, and then in brackets. Oh, there we go. Exception E. And basically what this does is, if there's an error, you could do something here, but we don't care to do anything if there is an error. We just care to say, try this, and catch the error, and just continue on to the next J value. All right. So I'm thinking of trying a bit of a bold move here. I'm going to say system, this is in the main method, system dot out dot print line possible moves. Now, let's just see what happens. I shouldn't get anything, I'm hoping, because in the default state, there we go, you got nothing. It did print out a blank line of nothing, but if we were to put an A there, now let's see what happens. Aha! How many moves do we have? We have 1, 2, 3, 4, 5, 6, 7, 8. 8 moves, which is absolutely correct. Now, if we put an A here, now if it's correct, it should find 1, 2, 3, 4, 5. The other ones are jumping on its own pieces. Notice 1, 2, 3, 4, 5. Exactly what we're looking for. And now notice if we put it in an edge where it'll check invalid places, we won't get an error. We'll just find 3 locations where A could go. And so this is exactly what we're looking for. And this is the format. Obviously, notice there's a space in between them, and that makes it look nice for readability. But really what that's saying is this is what's being captured. And obviously, because we add old piece at the end. So if I were to put a lowercase p there, for instance, one of these moves, hopefully, we'll have a p there. And then if I put a knight there and a rook there, we should have rook, knight, pawn, just like so. And so you have successfully now created possible moves for an A, omitting the castling. So until next time, enjoy Java.